Okay, we have reached 2.4, continuity. All right, we are talking about continuous functions because if we know a function is continuous, we can make life a little bit easier for us when it comes to finding limits. So, the definition that you really want to tune into is right there at the beginning of the section, that a function is continuous at a number a if three things are true, okay? That a exists, all right? That just means that it's in the domain, okay? If it's not in the domain, it's definitely not going to be continuous, right? That's if you've got an asymptote or a hole or something like that. It's also important that we have the limit as x approaches a of the function also exists, okay? So we've got to be able to find the limit and have it be something that does exist. Then the third part really fills in the fact that you can sometimes have those limits like you did in the quiz where you've got a hole and we can approach that limit from either side, but the function itself has a different value somewhere else. So we need to be sure that the limit as x approaches a of f of x is equal to the actual value of the function, that we bring that hole down and fill it in so that the value we get isn't some jump spot up above. So that as we approach from either side, it actually is that value. That is a critical point. Okay? So, a little example just to show you how it all works. If we have a graph and it does something like this, it goes along and it goes like this, and we have maybe another place like that. Okay. So where are the points of discontinuity? All right, well, it's really useful just to think that the word continuity is an awful lot like everyday use, that something is continuous if it never stops, all right, or if it is ongoing with no interruption. So if I can draw a graph without lifting my pen off the paper, that's basically the understanding, the geometric understanding of continuity. But we got some issues here, and why are these points discontinuous? Well, this place is discontinuous here because whatever this value is, call that A, call that B, and call this point C. We'd say it's discontinuous at A because A is not defined. That is not in the domain. There's just a gap there. There's a hole, and it does not exist. So this is not in the domain. All right? This one, there's a problem because when I go to find the limit, I can approach the value from this side and I can approach the value from this side, but they do not agree. So the limit here does not exist. No limit, okay, at B. Here there is a limit because I can approach from this side and I can approach from this side, but here the limit does not agree with the value. So that's that third part, that the limit does not equal f of c, all right? The limit value does not equal the actual function value. There's a jump, all right? So this we can call a hole, this we can call a gap, and I guess that's just a disagreement between the limit and the value of the function, all right? Okay, here's a pretty straightforward example like you might see in the book. It's actually problem number 31. Quick graph will help us do this. So we've got a piecewise defined function. If x is less than 0, it's just y equals mx plus b. We go up to 2. It cannot be at that point, so that's an open, and it's going like that. E to the x is an exponential. It crosses right here, and when x is equal to 0, I get 1, so I'm going to have a filled-in dot there. It's growing exponentially. And it goes up to, when x is 1, e to the 1 is somewhere around 2.71, so go up to about there, and that's equal to, so that's a filled-in dot. And then here it's a slope of negative x, aiming for 2, but that's when it's greater than 1, so I plug that in and it's going to be open circle about there, and going down that way. Alright, so these are just two linear and an exponential equation. All right, so where are points of discontinuity? Well, the points of discontinuity, as we've been thinking, is where we lift off a pen to redraw this. So discontinuity at 0, and this is 1 right there. So you could say discontinuity at x equals 0 and x equals 1. All right, but they also want you to talk about from the right or from the left, or else say mathematically why that is. Here the problem is that when I come at it from the left and come at it from the right, the limit at 0 does not exist. So the limit does not exist. That's the same reason right here. The limit coming from the left and the limit coming from the right do not agree. So that is why there's discontinuity there. It is not continuous purely from the left here because of the hole, that I need that when I get to that spot to have that value agree. But we would say that it is continuous coming from the right-hand side. So you can have continuity on one side or another of an endpoint or some sort of boundary. So we'd say it is continuous coming from the right towards 0. So it is also continuous coming from the left as we get closer and closer and closer to our value of 1. But it is not continuous as it comes from the right, getting closer and closer to 1, because this hole here means that the function value does not agree to the limit value. As the limit gets closer and closer to 1, it's approaching at point 1 comma 1, and because of the hole, those two values do not agree. All right, that'll get you started.